Okay, so where was I? Where did I leave last time? Hotmart. So I was doing the merge edges. Okay, so what happens with the amplitude? But I ended up doing something else. What did I end up doing? Apply gate, clean up original nodes, blah blah blah. The global phase factors thing. I was working on. What else I was working on? Oh, I was working on the apply 2-qubit gate being applied to actual sets of nodes. Because I wanted to I wanted these to be like you can apply it to a subset of nodes, not to the whole system. Because if the system is going to have branches, then we're going to have to go branch by branch and apply the 2-qubit operation in each branch. If that's, yeah. Because I think at the end of the day, that's really what makes a difference. I mean, it's not that it makes a difference. Well, no, just saying stupid things. It just each branch represents a whole state in which the system can be, right? If all the qubits in your system are part of a branch, I mean, you got to go through all the branches. If you let's leave the case where we have qubits in the system as well, but they are not entangled with other ones. So let's just focus on these. If we've got 2 qubits that are entangled, these 2 qubits are gonna naturally have like branches. They're just both going to be part of branches, and then if a third qubit comes in and gets entangled with one of those, this third qubit will then be part of these hyper edges as well. So at the end of the day, and that's why I'm using hyper edges, because you're going to end up having like multi-qubit edges, like not just with 2 qubits, but like with more than 2 qubits. Now, I'm trying to think whether I'm missing an edge case or not there. But let's try to get this to work, because now I don't know why is this complaining now. Print node. Node is not defined. Print n. So what is it doing now? The problem is that it's not printing the thing. And I don't know why. And I still don't know what to do with the amplitudes. That's still a problem. So what are we doing here? So we're taking a system, initializing a system, then applying a gate to Q0, Hotmart gate, and then we are applying and again, that's kind of hard-coded still. So this is hard-coded and needs to be generalized for 2-qubit operations. And I'm applying a control node with these control nodes to these target nodes. And it's wrong, I think, to call. Why am I doing that? Why am I calling these control nodes? That's wrong. That is actually really wrong, because it's a 2-qubit operation. It doesn't necessarily have to be a control. Why am I doing that? That's definitely wrong. Where is this function? Q0 nodes, Q1 nodes. Why am I doing these? That makes no sense at all. It just should be one. Oh, I'm stupid. It's because it's qubit 1 and qubit. Yeah, it's qubit 1, qubit 0 and qubit 1. Yeah, okay. I just, that's not wrong. I just shouldn't call this control. I mean, in this case I can, right? Because I'm applying the CX with these sets of nodes. Yeah, that makes sense, but it's qubit 1. Think about the fact that it's nodes of 1 qubit. It's just the qubit can have multiple nodes. That's why this needs to be generalized, and we need to put the qubit here, not the nodes here. That's okay, but just trying to get this to work now. So So I get the nodes, and then I apply the 2-qubit gate, right? And this gives me the system. Now, I need to clean up the system, right? So this is like, it's not reduced, but like merge branches, right? Merge hyperedges. So I get the entanglement hyperedges. Then I get the edge, right? So for each edge, control nodes is empty, target nodes is empty, print edge. And then I do for each node in that belongs to those edges, right? Print the node. If the node belongs to Q0, then pack it here. Let me just give me a second. Yeah, and I'm back and you didn't even notice. That's the magic of recording and being able to pause, despite the fact that I don't pause usually. Okay, so what I'm doing is, and this should be in the function right inside, is that for each edge, in the system, yeah, there's something wrong here. So I take an edge, and oh, yeah, no, I have to I have to take one step back, and it's just kind of like I literally did this a couple days ago and I forgot. So yeah, so it goes through each edge, and then for each edge, what it does is yeah, and so I'm going to assume if there's no edges, then this is just the system edge, right? Maybe like if no edges, there should be the system edge, or just the whole system, right? Which is just a neat way to generalize that. System edge, maybe. It's not. I'm not going to make an unnecessary edge, but like that should be considered this way. And then I have the control nodes, the target nodes within that edge, and then I apply the 2-qubit gate within that edge. Now, why is this? What is this? What is happening here? So, and I fear that that there's something messed up here happening because of the way the nodes are being handled. So we have edge 21, and there's a node 21, there's a node 22. And I think that's actually the node that causes a problem, isn't it? Node 22. Because for some reason, in this case, there's just a node 22. There's no other node. It says end of edge. I don't know why. Like, I guess what I should be careful here is, so I should print these things. I should print these things here, to be honest. Yeah, I think that's the, because I'm getting confused, and I think that's the reason. Edge 36, there's one node, there's another node, and then you have, this is the control, this is the target, and end of edge, right? Then edge 39, and this is no, there's not, yeah. So I actually can remove these because that's just, it's too verbose, and now I'm just getting the two edges, 51 and 54, and then the 52 and 53 nodes, 56, 50, 55, 56 nodes, which are kind of correct because the 2 are 0 and the 2 are 1 in here, right? And so what I want to know now is what happened when this was applied. Why isn't that? Because what this is doing, right? What this operation is doing is it's messing up with something, because then I cannot. I think I can get rid of these. Edge, blah, blah, blah. Mergeable edges. Oh, no. That's the thing about merging edges. Which... Yeah, which is actually solved, but I don't know. It's commented here because that's going to interfere with... Yeah, whatever. So... Okay, what's happening? Why isn't these printing stuff? Remember, what I want to do is I want to see that I just kind of get the same system that I used to get before I was running the merge, right? Because what I did is I really changed the 2-qubit operation so it can operate on 2 sets of qubit nodes instead of the whole system, which, I should probably generalize the... No, I don't need to generalize the 1-qubit operation because that's already, you give it the qubit and it just does everything through the nodes. But here I should just do it like that. So, but for some reason something's not working well. So what happens when I do this? Let's go back to this function. So we get the qubit, so we get the labels, the qubits, because we will need this later on for, edge addition and stuff like that. So what we do is for all the nodes in Q0 and all the nodes in Q1, right? What we're doing is we're doing the Kronecker product, because essentially what this function is doing is it's kind of getting the system representation of these 2 qubits, right? And within a branch, like I think it's a precondition here that qubits are not entangled, because the thing is, that's why we're doing it from within a branch, right? Like if the 2 qubits would be entangled, like that way of operating wouldn't work. That's why I need to go edge by edge, and then this will expand each of these edges into their own edges, and then when we kind of take a look back, like take one step back after this operation and take a look at the branch merging part, this will actually solve all the entanglement that might have gotten disentangled already, right? So that's why this needs to be at the hyper edge level, applicable at the hyper edge level. So qubits are not entangled. We operate at the hyper edge level. Exactly. So this is okay. So this actually makes these to-do irrelevant, because now it's like we know there's no edges in between, right? So we get the 2-qubit state, the local 2-qubit state vector. By local, I might be overusing these. What I mean is we expand these as the Kronecker product, so we get the actual state of that subsystem. Okay. We're gonna get rid of some of these things. We apply the gate, and we get the new state vector. And now what we do is this is as a to-do. I can definitely make that a loop to make it more general and better, and not like that I have like 4 ifs in here. I get these and I expand these into branches. So what I'm doing is I create new edges, right, for each of the wave function components. I give them their amplitude goes to the edge. We'll have to deal with this later. Then we add the edge to the system, right? We add these. So we're creating new nodes in this case. Yeah, we're creating new nodes. Okay, and then we add the nodes to the edge. And the nodes to the qubit edges. And this already gives the nodes the right. So I'm thinking literally to just get rid of the qubit edges. I think that is just. I think I'm gonna get rid of these. Yeah. I think it just might simplify debugging. I don't want these to be, so it's gonna make the visualization easier. So I don't want to add things to remove node, clean up the original nodes. I don't know if this needs to be, yeah, this needs to be done, but like, so what I need to do is in these functions, helper functions here, you create the vector qubit. So let me make sure that in the node labels we print the state, and we also print the qubit. Maybe have something like these that prints the qubit. So I want to know what is the qubit, and then when you create the node, get node labels, blah, create qubit edge, create node with this qubit. Yeah, this is exactly. So creating the node, so I don't need to do that. I don't want these, and I don't want these. So we're just literally creating the hypergraph, and these nodes are in no edge. I hope that works though. I think so. That should make it easier. Come on, that should really make it easier. Because a node really should. The thing is, a node should really just belong to one edge, and I think that's gonna make it. That's gonna make it more. That's gonna make it easier. So let's see if that works now. Let me just comment these out for a second, and we apply these, and then maybe we apply, yeah, whatever. We just apply the Hadamard gate, and then we print it. Just want to make sure that this works and doesn't break. Yeah. No. Okay, but we still got the edges. That's not what we want. Why apply gate? Oh, okay. So because we apply the gate and we add the node to the system edges with a qubit, and that's not what we want to do. State clone. Okay, so what is the clone doing? So it clones the node. Okay, so what I need to do is I need to actually add a little line here that says node qubit equals the cloning should clone that already. And we don't want these to be added to any qubit edge, because I think that is... Oh, but then we got two nodes. No, one node. What the heck? What the heck is going on here? So, so first of all, what if we don't apply? Let's say we're not applying any operation. Okay, but they're still being added. That's not what we want. Where is the function? Oh, there's an error. That's why. This did not. I think I cannot do this in Python, can I? Because of the indenting. That is definitely redundant. Did it break? No, didn't break. So no, it prints nothing. Awesome. Come on. Really? Dude. It's just nodes, no edges. I just want to show nodes, no edges. Print system nodes. It's empty. It's an empty hypergraph. What am I doing? From state vector. Oh well. Yeah, kind of, I guess. System at node 0. System at node 1. I guess that is a mast. Are you kidding me? HNX documentation. I am lost. I'm lost. I'm lost from state vector here. At node, at node. At edge, at node. I mean, a hypergraph without edges should still be a hypergraph, right? Like, I mean, it should still be valid. Edges, nodes. Add element, no, add node. Add nodes from. Okay. Add node to edge. Add nodes from. What is these though? From bipartite. Oh, what is this? Add edge. Node to edge. Add nodes from. Well, where oh, B is a graph. Add edge. Add edge from, but node to edge. Collapse edges. Like system non-name, blah blah blah. So I do have to add one at least. Okay, but it's not. It seems like it's not a bad idea. It's fine. We'll give it a. So we'll just call this system, right? And then can I have node 0, node 1? I guess that's fine. Let's not answer the amplitude. Okay, create. Not keep it, but I'll have like a Can I give it the properties? I think I can give it the properties like that. Hypergraph. Entity set. Elements. AB. So I can do it like these. From an entity, can I just do it like, so can I just do it like system edge, right? And this is like a entity which has an entity called system that has elements node 0, node 1, and it has amplitude 1, right? Can I do like this? And then I'll call this S, and then does this work? So now I should keep it. I don't get it. Because it thinks it's a node. It thinks it's a node. I want to create so what about system at edge S? Now, there you go, system 1. So we got node 0, node 1. Keep it 0, keep it 1. Okay, cool. So that's our system. I don't know. I don't like the fact that I have to have an edge, but like whatever. Okay, so that's gonna make things easier. Now, let's see whether I can operate on this. No, okay. Oh yeah, because now it goes through. Now I have to change the way. Now I have to change the way this works. So I need to go through nodes, system nodes, right? And then I need to get that, and node equals node, and it's like if node dot qubit equals qubit, then do the actual operation. If not, ignore this. And I don't need to do this now, right? Like, I'm cloning it up. And now I guess clean app. So, clean app. And then what I should do is, if the operation is applied, clean app n equals node, and then I should just go through all the clean app and not through the nodes to clean this app. Oh, that's not what we want to happen. We want so So apply gate. So we take a look at the nodes of the system. We clone the node, and then question is, do I have to clone it now? Can I not just change it? I think I should be able to change it. Come on. But that change won't propagate. That's the problem. It should propagate, to be honest. If I don't clone these, and if I just say node equals nodes n, and if the qubit is equal qubit, then node state is equals these, and then we're not going to clean up, and then we're not going to do any of these, and then we return the system. It's as simple as that. Please. Okay, that works. I'm just going to leave it like that. That's cleaner, no cloning, no crap. Ideally, I wouldn't like to just have to clone things just because I'm changing their state. That's like when creating new branches, I'll have to do that. Now, I think that kind of iterative refactoring is important. So, and I can, even try to just apply next gate here, for example, right? Yeah. So, and the system's got 2 nodes, and we're all fine. System 2 nodes, and we're all fine. Cool. Okay, perfect. Now, or even like Q0 and a Harmonic gate, we should go back to 0, 0. That's good. That's cool. Should be able to test at some point. Okay, now we have, and let's print the system. That makes sense. So we kind of, see how this is evolving. Cool. Now to the hard stuff. So we've done this now. Now we want to do again the control NOT gate. Okay. Perfect. So we have these, and then I'm collecting the control nodes. Okay, but now this is not. You know what I should do is I should have a helper function that says, give me the nodes for qubit 1 or something like that, right? How am I getting them? Am I getting them as in just the elements? It's just a dictionary, right? So I should actually have a function that says get, so where's this? Where's my apply 1 gate function? So it will look really similar. It will just be a function that says, given a qubit, give me all the nodes. So get qubit nodes. So system and qubit, right? It's the only thing that I want. And I want all the system nodes, qubit nodes, and so all I do is iterate, and if this is what we want, then qubit nodes n equals node. So I'm adding these to the collection, and at the end I just return qubit nodes. Cool. So get qubit node system. So now I need to go here and say, dear code, please, get qubit nodes from Q0, nodes from Q0. That feels much cleaner, actually. I like it. And give me the ones from Q1. Let me see. Let's just print. I'll call these Q0 nodes Q1 nodes. Let's just make sure this goes here. This goes here. So, but let's just print this thing first. Okay, make sure that it's okay. And then we apply the gate. And then we do all the other stuff. See what happens. Okay, error. Qubit. Get qubit nodes, get qubit nodes. What is it missing? Oh, well, system. Whoa. Okay, but it's printing stuff. That's not bad. That's not that. That's good, actually. That's really good. Hypergraph. It's printing hypergraph, and then what? It's picking the right things. Okay, cool. I think I don't need to print these here. So what is it really doing? Since the hypergraph, so we still have 2 nodes, which is not good. Where am I printing these though? I'm stupid. Of course it's good. Let's print it after. After these. First of all, let's just comment that for a second. So what has these? Okay, so now we have. Yeah, I see. The system one is just left like that. That's the problem. So, okay, because now I need to add everything to system one. So I need to add all the new qubits to the system edge, right? So I do need to do basically let's leave it like that for a second. I want to see if I can if this works without, like, I'm afraid having qubits that belong to multiple edges right now would just be problematic because of something wrong going on with the HNX behind the scenes. But that makes sense, right? So it created 2 edges, and this is qubit 0 and 1, both in the 1 state and 0 state, and both in the 1 state. So that actually makes sense, and we have the amplitudes set up correct. It's just the whole thing should be wrapped up by the system edge, but that's kind of correct. So that's not bad. So this means these has worked out well. If I take a look at the hypergraph, I'm gonna have to find, yeah. So there's the system edge, and there's the edge 32 and edge 35, right? Cool. So this is all, and I think I'm gonna really just wrap it up soon. Now let's merge the branches. So what's this supposed to do? So this is supposed to go through, get me all the entanglement edges, which at the end of the day, now this is just all the edges that are not the system edge. So I'm gonna keep it like that just because I don't want to get the empty edge. But that should be just replaced by get edges or something like that, right? And then I go through, collect the control nodes, the target nodes for that particular thing. I should change the naming, but like whatever. I print the edge and then the name, and then I say, okay, within the edge, I'm getting. So if the node belongs to qubit 0, then it's the control node. If not, belongs to a target node. So I do that, and I apply the 2 qubit gate. Okay, yeah, so sorry, I got to command that because that's not what I want now. I want to be able to. Oh no, that's correct. Now I have edges, so now I want to do that. I want to see if this takes me back to the initial state, right? Because that should uncompute the control node. Man, I should write this down somewhere. This is what I'm actually testing. They should, they should the problem is they should really also at some point clean up the edges, right? Okay, at least we're printing stuff, so that's not bad. It's just that now we have those two empty. I like that. It's basically it's worked. I think it worked. Yeah, because yeah, it worked. Nice. It worked because the 0, 0 stayed 0, 0, but the 1, 1, right? It actually went 1, 0. It actually applied the NOT gate to the qubit that it needed to apply it to. Now, here my question is, can I not just do I have to? I'd love to not create the nodes here, but I think I have to create these nodes. Then it just cleans them up. That's kind of okay, but I don't like it. I think I have to, right? Because I'm creating new branches, and then they have new nodes in there. Yeah, I think I cannot get rid of these. So yeah, okay, but it's worked. So it's worked just for the branch that I want it to work. And now I should just go ahead with the with merging the branches, which I am not so sure it works. That's probably not going to work. Let's see what happens. I get the entanglement edges, and then flag new edge. Let's see what happens. Okay, what's going on here? I think it worked, Wait a second. What is this? Yeah, I think it worked. I think that's the new edge, right? And I think it really just merged it. It's just I don't see the label properly. Is it gonna lay it out differently? Yeah, look at this. It worked. That's the edge. It worked actually. Oh wow, it merged it. Okay, that's cool. It actually merged it. But I still don't know how to handle the amplitude. But like it actually merged it. So we're back at one edge with these. Now that should be the system edge again, right? I guess. Or I don't know. That would be. Okay, but it worked. I just left a lot of trash along the way, but it worked. We have back qubit 0 is in the plus state and qubit 1 is in the 0 state. So that worked. Nice. Okay, perfect. So now we get at least. So we did actually a bit of a refactoring here. So we now have the 2 qubit operation that kind of works at the edge level. So just with sets of nodes. Haven't tested it well enough though. So I would have to abstract these away and to the proper 2 qubit gate function where I just give it the qubit labels, and then it should just do these thing as part of the function itself. And I need to, so that's going to be next video, and I need to actually clean up, because I like the fact that I'm not cloning in here, but here I must clone, and I must be careful with the whole cleaning up. And I'm really thinking about I should clean up the whole system every time just to avoid problems and kind of have a new system edge if need be. But I don't know. That's also not the right thing to do probably. So what this is doing, right, is it's applying these. So these actually will generate 2 new edges, but out of one edge. And so that one edge should disappear. We should clean up both the edge and the qubits in it. If the edge is system, then we should clean up the edge system and kind of have a new edge system. Maybe I shouldn't call it just system, Yeah. I think I shouldn't call it system. I think it shouldn't be anyhow special. It should just be an edge. it's like it's just one edge, right? And that splits in two edges. So I think that here we should definitely clean up the edge that these nodes belong to. To do cleanup edge and don't make system edge special. It should just be one entanglement edge. This is just one, right? Like we've got a system, and this system is sort of, it's not that it's entangled, but it's just one system. And so the system can branch out in multiple edges, but then, yeah, but then, no, but then the problem is once you have qubits in the system that are not entangled, you need that. No, you need that. That's the problem. Is that the problem is going to be when we have more than two qubits. Is that going to have qubits which are not part of any edge, and they still need to be part of the system edge. Yeah, so we need to keep the system edge special somehow. Cleanup edge. How do we keep the system edge? So yeah, that's gonna be the next. That's gonna be the next stuff. The next task, definitely. Perfect. But at least it works. So it kind of leaves a bit of trash behind, but it works. It gets us these, and then I need to clean up these nodes and need to clean up these edges, which are when I'm. Maybe that works now. What if I do this? Oh, there you go. What is it done? Yeah. Okay. So it works in the sense that it's cleaned up the nodes of the edges. Remove edge. But it kept the edges. That's a bit stupid, isn't it? I want to remove these edges. It cleaned up the nodes, but it just kept the edges. And that's a bit awkward. I don't know. And I don't see nice rubber bands anymore. So, okay. Yeah. I gotta figure out how to do this, but it's going the right way. So I get it to operate at the edge level. I get the merging right. Now I need to clean up the 2-qubit operation. That's gonna be the next task, and then I need to finalize the merging, because the merging needs to be iterative as well. So it needs to work until you cannot merge anymore, right? Until you have either just one edge or you cannot just merge anymore. So this is what needs to happen. And I think then we'll be almost done. We'll be really almost done. It's just I'll need to move to 3 qubits and see what happens if that whole thing works at all. Anyway, thank you very much for watching. Have a good day.